So I think one of the reasons that you decide to come to a place like UCSD, and there's always some contention between some rivalry, I guess, between whether or not you should go to a predominantly undergraduate institution or a big place like UCSD, and the advantages of coming to a place like UCSD, not necessarily because the quality of classroom teaching is better. Sometimes it is, but that's debatable. But really it's because you get to learn from people who are at the front lines, or what they perceive as the front lines of research topics in your field. And the other reason is because there's so much research happening on campus, and it's something that you can become part of if you know the right passwords and incantations to get you into a research lab. So you know, this campus is full of huge buildings, and you know, they're not all classrooms, obviously, or professor offices. A lot of them are labs. So I'm going to tell you a little bit about my experiences, and also how you might consider approaching getting into a lab. So first of all, what is research? Or if you were born before about 1960, research. Research is the systematic investigation of materials and sources to establish facts and reach new conclusions. Now, this applies to basically all areas of human learning, not just scientific research, but also journalism and law and so on. Scientific research is special because it includes all of this, but also involves producing new primary material by writing up the results of experiments. Engineering research still uses the scientific method, but it is application-driven, tends to be application-driven, and it tends to be based on higher-order phenomena. So phenomena that occur with lots of interacting parts, and generally you care a little bit more about things like error and systemization and signal-to-noise ratios and things like this. But you're still using the scientific method. It's organized a little bit differently, and its motivation perhaps is a little bit different. A lot of people are obsessed with the difference between science and engineering and really want to make a strict delineation between the two. I think a lot of times that's useless. There's no engineering without science, and you can't really do science without engineering, without engineered equipment and objects, and often they have similar goals. I think that a lot of times the distinction between science and engineering is based on how it's convenient to divide a university faculty, and sometimes these are historical accidents. At a university, scientific research is done in a laboratory led by a professor, also known as a faculty. Technically, the faculty refers to all the professors, but sometimes you call somebody, for shorthand of a professor, a faculty. Not my preferred nomenclature, but there it is. Principal investigator, or PI. Often in this talk, I'll go back and forth between professor and PI. That's what I mean. Sometimes the boss, even though these people usually have zero to minimal management experience. The PI doesn't do much of, if any, of the actual research. Instead, the role is mentoring, fundraising. This is big. Actually, UCSD is funded by the federal government at a level of about $1.1 billion with a B per year, which puts it in the top 5 in the country. That's more than Harvard or Stanford or Berkeley. Writing, ideally the PI is coaching the writing and not doing all of the writing. Speaking, so PIs go to conferences and other universities, kind of like a traveling rock show or something, and they go on their bus. No, they're just kidding. They go in economy class and give talks and meet people. So who works in a research lab? Research labs are staffed by people in several types of positions. Staff scientists, so I'm going to start in order of seniority and work my way down to juniority. Staff scientists, especially in the biological sciences. A postdoc, sometimes a postdoc is promoted to something like a staff scientist after a certain amount of time. Graduate students, this is usually the bulk of the researchers in a group, but sometimes fairly old or retired professors will have mostly postdocs in their group. Postdoc is like an academic residency. Like doctors have a residency, people that want to become professors usually do a postdoc, which is they get paid slightly more than a graduate student and have maybe slightly more responsibilities. Undergraduate students, visiting scholars, sometimes from industry, and technicians, especially in the biological sciences. Technicians can come in basically at any degree level, but they usually have a few specific tasks in the group. The research laboratory has at least one big theme. So I talked last Friday about one of the themes in my research group, which is the mechanical properties of semiconducting polymers. And within this one big theme, there might be a few different areas. And for example, you could have synthesis, computation, metrology, which is the science of measurement, device engineering. And each project is worked on by one or more people from this group. The goal of research is to invent or discover or understand something and then write a paper. So my old my PhD advisor said that if research does not generate papers, it might as well not have been done. And that's more or less true, because if no one finds out about it, it's just us talking to us, and that's kind of useless. Like, why does anybody do anything, right? Okay, so this was my undergraduate research paper. So just a little bit of an anecdote. I had no idea what undergraduate research was. I had no idea that universities had this thing called research when I was like a senior in high school. We went to the University of Rochester in my AP chemistry class, and we toured around a research lab, and I learned for the first time, I guess this was in 1999 or something, I learned for the first time that grad school in the sciences and engineering was free, and moreover, they paid you. And they paid you $17,000 a year, which sounded incredible. And so I thought, okay, maybe I'll think about doing that. And I had other career aspirations between the time I went there and between the time I actually did go to grad school. But then when I showed up at Boston University as an undergrad, I really wanted to get into research. So I applied to some summer research programs, and I got into a really particularly nice one called the Beckman Scholars program, and then it actually paid for my work for 2 summers in a row and 1 academic year as well. And this is the project that I had. So I was in a chemistry lab. I was not yet a nano engineer, but actually this research leads into my becoming a nano engineer. So these molecules were isolated from a sea sponge, actually from a bacterium that lived in a sea sponge off the coast of Papua New Guinea. And the researchers at the University of British Columbia that discovered these compounds realized that they had antifungal properties versus Aspergillus and Candida, which are fungal, the geni of funguses that infect immunocompromised patients. So the current treatment for these infections in immunocompromised patients is something called amphotericin B, which is a very harsh drug. If you take it, it causes damage to other organs. So there's an alternative was needed. So using these techniques from organic chemistry, I was able to, my grad student Neil kind of designed the first generation synthesis, but I performed all the experiments and got to this thing. And this is the NMR, the nuclear magnetic resonance spectrum of the natural material and the synthetic material, and you can see that they're the same. So seeing that was like the happiest day of my life. So 85 papers later, and this still was the most gratified that I've ever been at the end of a project. Okay, so then I did another project, which interestingly, I did this project at the end of my, after I graduated from BU and before I started grad school. I did this project in the summer, and I had a roommate, like a randomly assigned roommate, who played Counter-Strike, which I don't know if that still exists, but played Counter-Strike all night in a studio apartment. And so I moved all my stuff to the lab, and that's how I was able to get a second paper out of my undergrad research, because I didn't spend any time at home. But I also burned myself out of this topic completely by the end of this project. And then when I started grad school, I had no idea what I wanted to do. But anyway, it was a pretty cool project. It was about doing this chemical transformation that involved a few different things, and you got something really complicated out at the end. But the cool thing is that it was catalyzed by this porous polystyrene sulfonic acid, which had these nanopores in it, and you could recycle the catalyst. And I got really interested in green chemistry and nanostructured materials, and that kind of led directly to my later research interests. Okay, so why do you want to do research? Why does one want to do research? And there are many reasons. One is because you love it, you know you love it, or you think you might love it, and you're testing the hypothesis that I'm going to love research. So you do research on research by doing research. Do it because it's what you feel you're supposed to do. Like maybe you have friends doing research, or you figure that you're at UCSD and there's all this research happening, so you might as well do it. Because it's cool, and it is, and that's a legit reason, and because your friends are doing it, and that is also a legit reason to do it. The scientist, and I'm going to say that the researcher, and I would say that an engineer doing research is also a scientist. So just so that we don't have any, just so that we don't perpetuate the rivalry between science and engineering any further. There are 3 archetypes, and these were identified in a really cool small book called Letters to a Young Scientist by Edward O. Wilson. And there are 3 archetypes, and you can figure out which one you fall into. There's the one who's motivated by the quest, so the quest to discover or invent or understand something, and that's really appealing. There's the Holy Grail, where once you discover the cure for this disease, or you make this algorithm that's going to solve the energy crisis by redistributing energy on a grid, or you make the world's perfect solar cell, that's like the Holy Grail, and that's what motivates your quest. And then the third one is a little bit of a cynical one, but I would say that I probably fall into this maybe 60% of the time, and that's good versus evil, where maybe there's some evil in the world that you feel can be cured if only, or defeated, if only you were to come up with the right technological solution or scientific understanding of some process. There are also reasons why you should not do research. One is for money. Very few researchers end up making a lot of money, but if you get lucky and you're good at it, you do okay. You do okay. You should not do it for a line on your resume, especially if you're applying the last half of your senior year, because that can look a little suspicious on the part of the PI to which you're applying if it's really late in your undergraduate career. You shouldn't do it for a recommendation letter, but if things go well, you will get a good recommendation letter, which will really help you in your career. And you shouldn't do it just to make up for a GPA that you feel should be higher. But instead of doing research, I would try to get this to a level that you're comfortable with and not try to do it do research in a compensatory manner. Okay. There are costs and benefits to doing research. It is not for everybody. In fact, often it sucks for weeks at a time and you want to smash your equipment because sometimes nature doesn't work the way that we want it to, and maybe the phenomenon that we're looking for isn't actually there. Maybe we're testing the observation that we made on which we're building we built our hypothesis and our experimental design was kind of a fluke, and maybe we can't see it again because it wasn't real. Maybe it was an artifact or something. It can really test your mental health, because when things don't work over and over and over again, research isn't necessarily one of those activities where if you do it, ultimately it gets done, where you work on it a little bit like you're painting some rooms in your house, like I am right now, and you make progress every day, and then by the end it's done. Research doesn't work like that. It kind of works in fits and starts, like punctuated equilibrium, kind of goes and then maybe it plateaus for a while. Be prepared to work long hours in the lab, at least 12 hours per week, usually more. My undergrad research advisor required 25 hours per week, for better or worse. And then this leads to, it can really test your mental health. If this is a toxic thing, if it turns out that you feel you're being forced to do this, then you don't want to be there. You want to be there because you want to be there. While you will be spending a long time in the lab, make sure you're doing the right things and not just putting in time for time's sake. Escape toxic situations. You can always find another lab. There are like 2,000 labs on campus, literally. The friends you make will be some of the strongest bonds that you make in life, because it can be a mentally, emotionally taxing situation. But the people that you share that experience with, you will have as friends forever. So there are some really good outcomes. So these are people in the classes that I've taught that have gone on to grad school, that I've written letters for, people in my own group. So I've had students go to grad school, PhD programs in a number of really good places and a number of really good companies. So basically all of the top tier companies and grad schools. But it does require a pretty significant commitment up front to achieve these things. So how to get an undergraduate research position. So all the professors kind of say, do research, do research, do research, but don't really provide a recipe. So it's not really a recipe. A lot of people in life will try to give you advice, but what they really do is they tell you what they did and then expect you to do exactly what they did in a way as to justify their own life choices. But these are some things that if you do them enough times and you want a position, eventually you will get one. So talk to your TA. Most of your TAs are graduate students in a lab. Often they're graduate students in the lab, in the professor who's teaching the course, although some departments don't allow that. They don't allow the professors to choose TAs from their own lab. You can develop a relationship with your TA at office hours and so on, since it is her or him who will do the bulk of the mentoring once you're in the lab. So the professor isn't with the student in the lab on a day-to-day basis. It's usually the grad student or the postdoc who's doing the day-to-day mentorship. And then eventually you get more experience and you work independently. You can talk to your professor directly. But we receive hundreds of emails a year from prospective students, visiting scholars, and postdocs. So it's really important that your emails stand out, and I'll talk a little bit more about emails in a bit. If you meet the professor beforehand, then by the time you send them an email or show up to their office, they'll know who you are, and then you'll have a much better chance. But a cold email, unless it's really, really well done, probably won't lead to a face-to-face meeting, just because of the sheer volume of emails that we get. It's just the truth. This is a really good piece of advice, if I may say so, even though I said don't believe anyone if they call it advice. Read some papers, especially those written for a more general audience. So a research lab will have, if you go to the website, it'll have something, publications, and then there'll be like whatever, 100 publications, and most of them will have titles that make absolutely no sense whatsoever. So what you should do is not try to understand that, basically it's written in a foreign language. What you should do is find some of the articles in journals that say something like review or reviews of whatever, or you find a title that you can understand, and maybe it was either written for a popular journal or magazine like Scientific American or something like that, or Wired or something, and read that. Also, sometimes technical journals will have articles that have a tutorial goal, where they have a pedagogical goal, where they're trying to teach people entering the field for the first time. And usually the titles of those papers make much more sense to people that are not in the field. And you can find these on the research group's website, or if they don't do a good job keeping the website up to date, you can also find them on Google Scholar or PubMed, or if it's a biomedical related field, or ISI Web of Science, Web of Knowledge, and we have free access to that through the UCSD library. And in your email or face-to-face meeting, tell the professor exactly why their work interests you. Make the costs low. So make the costs of engaging. We have lots of demands on our time, so make the professor's costs of hearing out your case as low as possible. And that's often by asking to go to one group meeting. And I would say, like, not go to group meetings indefinitely, but is there a day where I can go to a group meeting, particularly where a grad student who's talking is talking about this, the topic that I read about or I'm particularly interested in. And if you say just one, then you could get invited back. And use that time to talk to the grad students whose work interests you, and you don't have to ask questions, during the group meeting because that's super awkward. But sometimes there's some time at the beginning and at the end, and the professor will say, "We have a guest today, so and so," and usually, there can be some mingling at the end. This can't work for everybody because there just aren't enough of these summer research positions available, paid research positions available. But if you apply for a summer position like an REU, which is started as an NSF program that stands for Research Experience for Undergrads, you can force your way in by saying, like, I have this funding. And I need a lab. And usually the professor already signed up to be part of this program and is obligated to take people that want it. This is key. Is this the? I don't know. If you're funded, you're free to the professor. Some professors usually have some amount of funding that they can pay summer researchers, not as much as you would make at an industry internship, not nearly as much, but might have some slush funds. And if you're the right candidate, or maybe the second summer that you've done research, you can actually get paid for it without getting a fellowship. So emails, a little bit about email etiquette. Make sure that you attach your resume or curriculum vitae, and make sure you attach that to your email. Include a cover letter, or better, just put it in the body of the email, because we don't want to open 2 documents that's like 4 clicks. Avoid the most common mistakes, and that is sending the same email to everybody. Sending the email from your goofy high school email address that might not be your name at gmail.com, but maybe like, I don't know. Kittens 420 what? Yeah. Addressing the professor as the wrong professor, which has happened many, many times. Addressing the professor as hey. Granted, most of my emails to people that I know do start with hey, but it's, you know, there's a time and a place. Don't address by the first name unless that's kind of been cleared beforehand. It's interesting, there are geographical rules for where professors are addressed by their first name, or Professor so-and-so or Dr. so-and-so. I found that in the South and West, it's always Doctor or Professor, even through grad students and sometimes postdocs as well. In the Northeast and some places in the Midwest, but definitely the Northeast, as soon as you're a grad student, it's all the professors are their first name. And usually the undergrads in those labs, it's also the first name. And then sometimes you see a greeting that's not something that's used in American English. And I don't want to be too specific about this, but just dear Professor so-and-so is fine. Don't use anything else and you'll be okay. Spelling errors. So avoid spelling errors. Avoid bragging. Sometimes this happens. All right. There was space. I thought there was another bullet. So avoid bragging. All right, examples of how this has worked. So students that have successfully gotten into my group, I should say I'm giving this talk right now at a time when I'm probably not taking an undergrad this year, but that could change, who knows. But probably like 0 to 1 this academic year. So these are examples of how this has worked in the past for my group. So one time a student came to me in convocation or orientation. Actually, this happened one time in convocation, a few times in an orientation program where they were clearly the most interested in nanoengineering or chemical engineering research, and asked me a ton of questions about what it is that that my group did, and eventually they got invited to be in the group. Often top grades in courses, so I will look at the quizzes and the exams and find like creative answers to things, and sometimes like if that person emails me later, I'll remember who they were. Fellowship programs. So for example, at UCSD, we have a lot of different fellowship programs. IDEA Scholars, McNair, Liddell, STNI, San Diego Nanotechnology Infrastructure or something, UC Leads program. There are many others too. These are just some examples. Often they're brought in by a TA. So I was talking about this before, where I've had a TA in a course that met a student through office hours. Sometimes you get a beautifully written email and followed by extreme preparedness for an interview. And this is an example of an email that I got from a student who ultimately ended up in the group. And one thing you'll notice is how long and specific it is. And it's a little bit like the essays on an AP American History or AP European History exam. It's like to a 0th order approximation, your score on the exam is determined by how long your answer is. You don't want to be absurd, but this is a solid, good length. Same thing is true for recommendation letters. So make sure that when you ask for a recommendation letter, that you ask for it from someone who can really fill up, the 2-page limit or whatever at 11-point font with 1/2-inch margins. Okay, don't insist on any of that, but have an idea. Okay, be persistent. I've turned down most of the people that I ultimately took. I think this is one of those things like, probably like book publishing. If you look at industries that just have lots and lots and lots of rejection, I think that most successful authors tend to get turned down a lot. And you see this over and over and over again, where a very successful book just gets turned down. And it's not because the person doing the turning down is malicious. It's because they have a lot of other commitments that they've already made. And by taking on extra responsibility, they're actually reducing their ability to meet commitments that they've already made. And that's really what it comes down to. It's not because people that do the declination are being mean. Although, well, there's more later about that, about rejection. So all who got in were persistent. And the fact is, this is attributed to Daniel Kahneman, who is a psychologist who won the Nobel Prize in economics several years ago. The book is Thinking Fast and Slow. If you're interested in this, I would get the audio book because the paper book is really, really thick, and we have other things to do. So if you don't get rejected with some frequency in life, you're not taking enough risks. It's just the way it is. Like, there's nobody that has such focused crosshairs on what they want in life that everything they want they get. And probably if they get everything they want, they could get a lot more. They're just not failing enough. So if the professor responds thoughtfully, take their words at face value, and don't take it personally, everybody gets rejected. People with a lot of, quote, success get rejected even more often. Professors, our business is to get rejected. So this is my profile from my National Science Foundation Fastlane, the website that manages all the grants. And what you notice here is that the mode outcome for the proposals that I've submitted since I've been at UCSD is declined. In fact, only one of these has been awarded. And I took the screenshot 2 days ago, so there were a couple that are pending, but yesterday this one went from pending to declined. So this happens over and over and over and over again, but you just have to keep going, because if I didn't apply for this one, I wouldn't have gotten it. Okay, there are other agencies where my hit rate is better. I'm 1 for 2 at NIH, and the one was a big one, and I'm 2 for 2 at the Air Force Office of Scientific Research, and 1 for 1 at the California Energy Commission, thanks to a colleague. I try to take credit for that proposal, but really it was his. Okay. What is a day-to-day life in a lab like? Learn and read. When you're there, try to learn as much as you can and read papers. Get lots of instrument trainings, because at the very least, even if you don't get a paper out of your research experience, at least you'll be doing photolithography or nanoparticle synthesis or animal work or something, and those are all pure gold to put on your CV or resume when you're applying for a job or to grad school. If you have lots of instrument trainings, maybe sometimes the undergraduate is the one who is doing all of a particular type of measurement, and that allows you to get involved in multiple projects because you're kind of the keystone to that project. That happens a lot. And develop your superpower. So what is it that you can do in the group that other people don't do? Don't ask for your own project right away, because one, the optics, that's what they say in politics, the optics of this don't look very good, because probably you're not that, this is probably going to sound bad, you're not experienced enough to know what the impactful project in an area is going to be, but you will become so eventually. And even I've been doing research consistently for 16 years, and I would say that still 9 out of 10 ideas that I have are crap. So work hard, but mind your mental health. This is key. If it's not for you, find a new lab. If it's still not for you, that's okay. Don't freak out. If it's still not for you, that's fine. Research is a very specific thing that only a very tiny percentage of people are doing professionally, but there are lots of other parts of R&D that do not involve banging your head against a wall searching for the solution to a problem that may not actually be there. So it's okay. I've found that it's been the right thing for me and most of the people that I deal with professionally day to day, but it's definitely not for everybody. A lot of people have gone on to the development side, not so much the research side, and that's perfectly fine. All right. And at this time, I am happy to answer any questions.